hand hold it if you want to go.
Yeah.
You could like pick it up in your hand and it would be like Blair Witch.
If you're that close, then I don't see your face.
We could end and I could face into the corner. Sorry to spoil it for anybody.
A necklace around Ben if you like.
Yes, stay sort of on the back because up to then I don't see your face. I mean,
Wait.
there. Yeah.
How do I, let me just,
You need the laptop closer.
let me just do this. You'd think I would know this stuff pretty well, but as it happens.
Just like tilt it up a little bit. That's the ideal use for a tablet. There you go.
Then I have to hold it instead of gesturing wildly. Who the hell designed this crap?
It sounds.
Okay. All right, tell me when I should go. Oh, okay. Well, then great. Well, I figured I'd give this overview of views in Aura. I know that you guys have all been using this stuff pretty extensively, so feel free to interrupt me if I'm covering something that's boring or have other questions. But the structure of it will be talk about views, Aura, some of the specific pieces of code that use views in Aura, some of the window management functionality that we have, and then what we build with views in Aura in Ash and Desktop Aura, project that's most interesting to you guys, and then some of my opinions about where the framework could go in the future. So back to the top of my notes. Views is the oldest piece here, and it originates back with the start of Chrome. Very quickly with development of Chrome UI, we found out that just native Windows APIs were not sufficient for doing the kind of user interface that we wanted. We wanted to have transparent child windows or like child controls that had like alpha blending with the stuff behind them and various other bits like that. And then like writing all these Windows procedures and then trying to do other hacks was a bit of a pain. So we built views, which uses Skia to render. And so the core abstraction of views is a view, the class view, and it has a number of different responsibilities. First of which is that views are in a tree. There's a tree of views, child views and parent views and various things starting at the root of a particular widget. And actually I'll draw this up here so I can keep referring back to it. There's a root view, and then you have some arbitrary nested hierarchy of views. And so views know how to traverse this and also know how to perform operations into this tree. Some of the tree operations include event targeting and handling. So if I have a mouse event and I want to know which view it gets targeted at, it just goes down into the tree and finds the view that most tightly encompasses that point. Things like paint processing come down into the tree and then go back up the tree when like this view wants to mark itself dirty. It calls schedule paint, which like bubbles all the way back up to the root. And then various disposition. Non-tree things are disposition changes. Like this view might want to change its bounds. And that might just be as simple as moving slightly, but that might also trigger a layout manager that's attached at its parent to do stuff, and I'll talk more about layout managers in a little bit. But these are the kind of different responsibilities that views have. The standard way to use a view in Chrome code is if you're writing some piece of UI, you might use existing view controls that exist, like buttons. There might be a toolbar or web view or something else that you need, a tree view, and you would instantiate those. You may also subclass view, not only to specialize something like a button, like let's say you want to make a special kind of button. A special kind of button is a radio button or a checkbox, for instance, which are just subclasses of button. I'm not sure if that's still the case. That was the case at one point. And this is one of the things I'll get into later, is one of the parts of views that I'm not as happy with. A lot of times, even just to implement, to use views, you will subclass them. And so if you're making a dialog box, a common pattern is to create a view for the dialog or subclass view and have that be the content of the dialog box. and then that will also serve as the controller for that piece of UI. The tricky aspect of this, the reason why I'm not as much of a fan of this, is that the API for Vue has never been given that much thought as far as what is exposed publicly. Maybe some thought for that, but less so as to what is exposed vertically to subclasses. And so it's not really well defined what happens sometimes when you override some methods that are intended mostly, or at least in my mind, were intended for the implementation of views and not for client code to be dealing with, and then sort of calling back or not at all arbitrarily. It yields some interesting results. But anyway, that's kind of how people are using it today. Views are, the ownership model of views are the tree owns the views by default. So if you create a view and you add it to another view, you don't need to worry about deleting that view. That view will be deleted by this view and so on up the chain. The root view is the top level view, and that's owned by this thing called a widget. And a widget is bound through an interface called native widget. To some implementation of which we have several, and you've all seen this stuff. On the Win32 land, there's an hwind here. And so when this hwind is WM destroyed, it'll destroy its widget, which will delete the root view and thus the whole tree.
So native widget implements an interface of widget.
Widget does not, native widget win implements this interface as an interface, and then widget uses this interface to talk to the underlying platform type. Optionally, there's some code that wants to instantiate and manage the lifetime of a view itself, and so you can change the ownership model of views. Most often this is tests. There are a few other cases at various points in time. I'm trying to think, maybe this would be better for the Aura part of the talk. But sometimes you might need to control the lifetime of a view independently of the tree that it's attached to. And so in that case, you would change the ownership of it not to be owned by its parent. I mentioned layout managers. A layout manager is it's an interface that basically says, given some child views, I want you to change their bounds, to put them in whatever layout makes sense for this container. And so a layout manager would typically be associated with a parent view, and then child views, when they're added, would be positioned within that parent according to the rules of the layout manager. The most interesting and complex of these layout managers in views is grid layout, which has a huge amount of flexibility for laying out dialog boxes according to various rules of columns and rows and spanning and flexibility properties and preferred size and that kind of thing. I mentioned preferred size too, which is another interesting thing. Even if you're not using a layout manager and you're just writing your own layout method, to lay out your, the flow basically goes, out here you have your native widget, like your hwind. And when this is created and sized, it updates the widget, which updates the root view. And the root view is always sized to fill the content of the hwind. And then, so its bounds change, and then all the way down through here, it basically gives the opportunity for these guys to lay out according to the new bounds of their container. And so sometimes there'll be a layout manager here that'll handle this for you automatically that you might have picked and set up. So you might have created a grid layout manager and associated with one of these guys. Or your view subclass might override the layout method yourself, and then you might just do something ad hoc in place where you say, oh, well, this child goes here and this child goes there, and that sort of thing. And instrumental in that is another method that views override called getPreferredSize, where a view measures its content. Like if a view is a leaf node, maybe it paints an image or image plus text or something like that. Then it can measure the text and measure the image and so on, and whatever padding and spacing, and return some size that is used by the parent to lay it out. So that's sort of the flow of layout. And there's some, some subtlety and complexity in there. I think there's the view system knows that things need to be laid out and various other bits and pieces, but it mostly just works.
Rendering inside the view state, do we see a context?
That's right. So at the top level, and I'll keep on referring to the HWin type because this is the kind of the classic example of views, even though we're busily replacing it with this new thing. Out here at Native Widget Winland, when you're told when you get W in Paint, you get given a, or you call begin paint, and you get a device context. And then there's a SK, was it platform canvas or something? I can't remember what it's called. You construct a DFX canvas, which is just some syntactic sugar on top of this canvas paint thing that takes the device context. And then I think it has a, I think it must be, there's probably a buffer in there, like it's double buffered. And so then you draw, basically you give this canvas to the root view and tell it to paint. And then basically it enumerates the children. And when it walks into the children, it like translates in clips all the way down so that each view only renders into itself with whatever its current bounds are.
Why do widgets and views need to be a different concept?
This is a historical thing, and this is an interesting thing. I'm not sure that they necessarily do, and I'll get to that more at the end when I'm talking about what I'm thinking about right now. But the widget just became the interface. Originally, it began as the interface between a hierarchy of views and the platform concept of a window. So like in the earliest days of Chrome, there wasn't even all of this. Like if I have native widget win out here, I'll just do native widget win. Like this whole part of it didn't even exist, and widget just had like Win32 code in it, so this was somewhat simpler. Then we began porting views to other platforms, and then like all this other stuff crept in. And the difference between, the reason why there's this and this is that there was a lot of code up here that was cross-platform, and then like a very specific subset to do with receiving platform native events and platform painting messages and stuff like that. So that separation happened. And then there's this root view as well, which I'm not sure needs to exist, especially because the root view, what the root view does mostly is just handle event targeting. It like figures out which view should receive mouse events and so on. It's I think some of the stuff could be cleaned up to be a little bit simpler. That's just sort of where the code is organically grown. I thought about, like after working with this for some time and trying to improve this, with the development of Aura, which I'll get to in a little bit, I tried to make that somewhat simpler. It has a much more focused set of responsibilities, so it doesn't have to do as much, but it's also much simpler. And so I wonder if we can make some of this a little bit less complex. There's a large control library under source views control, UI views controls, various things which you've probably all seen. I talked about the widget and the root view and what they were supposed to do. They're thinking originally we used to have different types for widgets, which were just child windows and like pop-ups and stuff like that, and this other type called window, which is for a top-level window. But those seem to be very similar, and they're eventually just smashed into one. And so widget basically handles any type of widget, just like HWin can be a top-level window or a child control. I mentioned native widget as the interface to the platform-specific thing. Of course, this side of the native widget divide is much more complex now. We have native widget Win for the non-Aura case. We have native widget Aura for the Aura case. We have desktop native widget Aura for the desktop Aura case. And then we have, what else do we have? I can't remember. We used to have a GTK one that Chrome OS used, but that was killed. And I'll lament that some more in the Aura section. But ever since the development of the desktop Aura project, the structure of this side changed a little bit. It used to be that this code here talked directly to the HWin, but implementing a custom frame like the Chrome UI with its handling all of the various non-client messages, there's a reasonable amount of complexity and busy work to be done there to make Windows happy. And so it seemed a shame to have to duplicate this work, especially since we're constantly bug fixing it. So a lot of that logic got split out of here into HWin message handler. And then that just added another layer on the back end of this. Hooray! Oh my, yeah, let me write this with proper handwriting. H1 message handler. And so we have another layer there. And then we have desktop native widget aura, which has a desktop root window host, which I'll talk about in the aura section, which has one of those. And then we also have native widget aura. This implementation is very much like this in that they consider themselves to be top-level windows, but it doesn't think it has to speak to a higher power. Like it just thinks that it's talking to an aura window, whereas this desktop type knows that it has to go through and do some extra work while also wrapping an aura window. It may not be the crispest explanation of that. Then within this side here, I mentioned the controls, but then we also have to implement the various bits of Chrome UI. We have different window types. We have like the browser window, which has its own custom frame type with the weird tabs that extend into the frame and no title bar. We have like the dialog and bubble styles, bubbles that have that kind of rounded border with a little arrow. We have various other dialog styles, some of which look more like conventional Windows UI and some of which look different. And so to implement all of these, originally in Chrome, when we started doing these, people began writing custom views that implemented all this custom frame logic in situ, such that one dialog box would look different from the next one for no reason other than that different people implemented them, which was sad. So I tried to consolidate all of these. For window type widgets, they have a non-client frame view. All this terminology, of course, inherited from Windows. So a view that is responsible for rendering what we would consider to be the non-client area, the caption, the borders, and all that kind of stuff. A non-client frame view, one of its has a couple of important methods that it has to implement, like some conversion functions that do conversion from client size to client size to non-client size, to subtract the size of its caption and frame, and to do hit testing to return like the NC caption, HT caption, HT left, right, bottom right, all of those kind of things that you know where you clicked on it, so that we can pass it on all the way back through here out to the H1 when we handle NC hit test.
And the frames do not live in this tree, right?
They do. The frame. So there's the non-client view is here, and then the non-client view has two. I'll explain how this works. So there you have the root view, and then you have the non-client view, and then you have the non-client frame view, and then you have the client view. Those are peers. They're not children of each other. So this one, every window type widget has a non-client view, and then some implementation of this abstract class. Like there will be various types for bubbles in the browser window and other kind of stuff like that. And then this is where the content of the window goes. The reason why this isn't a child of that is that there are different implementations of this for gloss versus non-gloss. So when you install a theme, for instance, we need to be able to change the frame type, or we swap out that view. And another unfortunate side effect of views is that a lot of views use the fact that they were added to a hierarchy to perform once only initialization. So if we were to rip them out and then reparent them to a different view, various hilarity would ensue. And so that's why we have this kind of split here where we can swap out this guy without affecting the content of the window. It's possible to construct a widget that doesn't have any of this, but that would not be a widget of type window. That would be a widget of type something else, type control or something else, in which case you can construct an arbitrary hierarchy in here and do whatever you want. So
You said the client view is a sibling of the non-client view?
it's a sibling of the non-client frame view. The non-client view
Okay,
is
yeah.
just like a node that contains the two of them. It may have some pass-throughs to this guy for the widget's benefit. few other notes.
Are child views always clipped to the bounds of their parent view?
I believe so. The painting does that for them. Unless, so another interesting property of a view is that a view can optionally have a layer. We've never actually used this, I don't think. I can say a little bit of the history of Aura. Originally, when we wanted to add hardware-accelerated effects to the UI, much of this initial work was done out of Waterloo. There's a team up there that were working on an interesting prototype. They started by taking the view hierarchy, and then they added a texture to views optionally that they could support, and then there was a bunch of metadata on the view as well, like the transform and various other things. And so at some point I decided that we should put all of that into a class called layer. This was before we used CC for the UI. It was actually a separate compositor called Browser Compositor that lived in Source UI Compositor. Views optionally support the concept of a layer, and so a layer can be transformed outside its logical bounds and still be seen, so it won't be clipped. That's one way that you can get that effect. Another way to disable that clipping, I guess, would be that you could somehow override the paint processing at the parent that does the clipping. So I guess it just depends on what you need from the specific kind of UI that you're building.
Was there any particular reason to keep Aura separate from views?
Yeah, so that's an interesting question. Maybe I'll cover that. I have some notes for that in the Aura section. I'll just wrap up the last couple of views items here. A couple of other points of note real quick. We used to use child HWinds quite extensively in views because we used native button widgets and stuff like that. So we had to have the ability to host native widgets inside of a view hierarchy. So we have this type called native view host. Now we've transitioned away from that, where we actually have our own button class that just uses the Windows theme renderer to render something that we think looks like a button, that Windows would consider to look like a button. And I think we may even be migrating away from that with some of the new visual designs that the design team is coming up with. But we still have native view host because things like web contents just exposes a GFX native view or native window type to us. And so we need to have a way to embed that in a hierarchy. So a native view host basically takes a GFX native view and will keep that sized to the bounds of the view that it's attached to. And like I said, that's used for the content area of the browser and a few other places like that. Any dialogues that use web contents will use one of those to host them.
But I don't think Aura has more windows.
No, but in Aura, the Aura window is considered to be a native view. So if you want to embed an Aura window within a view hierarchy, you'd use a native view host to connect it. And then that would, the Aura specific implementation of native view host will size that Aura window to match the size of the view.
So native view host, where does it live today?
It's under UI views controls, native, I think. And so WebView is I think it makes use of native view hosts. It's just provides some niceness to native view hosts specific to hosting a web contents, like load this URL, which is like the common pattern people would do with dialog boxes that had some embedded web content. Views also has accelerator support and stuff like various focus stuff. I'll talk a little bit more about focus later. But you can say that on a dialog box, you can have the OK button register an accelerator for the enter handler, which some of the default dialog utilities do, so that when you press enter anywhere in a dialog box, it'll try and accept the dialog box and stuff like that. And there's IME handling and stuff like that, where the incoming event stream through here will get routed through either the platform native or, in Chrome OS's case, our own IME system, and then it will come back with translated key presses, and then it will come and be dispatched normally as a key event. That sort of completes the views side of this. I don't know if there are any other views questions.
So in the lifetime when the native window, when the H.20 gets closed, so that propagates that way and then it unwinds. the other way. Because we sometimes get bugs where the native window gets killed and we are not.
I've always tried to design, so the question is that the lifetime is, should the lifetime be such that everything is basically handled correctly when the H1 gets ripped out from underneath you and destroyed? I think that's...
Yeah, or sometimes you want the views to exist even if there's no backing HWMD.
Okay.
In some cases.
Yeah, sometimes you might want to have control of your view beyond the lifetime of the widget that contains it. My assumption with designing the Windows parts of this has always been that anyone that has my H1 can call destroy window on me at any time, and so I should treat the WM destroy as like the signal that I'm going to die, and not try and invent my own destruction signal. And so that will cause a sort of a cascade through here and the destruction of everything else. So if you want your view to live past the lifetime of your widget, then you have to specify that you own your view. And then the hierarchy won't attempt to delete you, but whatever object you have that owns the view will have to take care of that. So you get that flexibility. Just know
Does
that
that
that's...
correspond to that flag that says like native widget owns view or view owns native widget or something?
Oh yes, that's another thing. Typically, I believe, if I'm remembering this correctly, the native widget owns the widget. Again, because of the model where I'm just trying to anticipate that someone's going to try and destroy this H-wind out from underneath me. And I'm assuming that this is all completely analogous to X, that someone could try and destroy your X window.
Out from under you, yes.
Yeah, and so basically the idea is that the platform native window will get destroyed, and so it has to know to destroy this guy and then know to destroy the rest of this. So that's kind of the default ownership. The reason we have the other option is that a lot of tests want to just create a widget on the stack and do something with it, in which case, in that situation, just for simplicity of writing test code, the ownership has to be reversed in that case, because the widget can't be destroyed when this guy goes away.
So, like the other case, like when you create the widget and then destroy it when you want, isn't that the more obvious way to, like when you consider that from a user's perspective of the framework? Like the user wouldn't care about views or whatever. You're just going to create a widget and once that shows up on the screen, all the current is done and when the functionality over, it closes the widget. Instead of, wouldn't that make it simpler?
So there are methods on widget to close. It's just that these, if you call close or destroy or whatever, these propagate out to here, which tell Windows, close this H-wind or destroy this H-wind. And then that lets Windows do whatever cleanup it has to do. And then Windows notifies us back that that actually happened, and then we clean up. So what we can't do is we can't have close here and then go and do a bunch of stuff and then like notify out here. It's just, it's simpler for us to sort of forward this over to the H-wind and then let Windows notify us back that that happened. Because then that also handles the case where we didn't initiate that ourselves. For instance, if I use some Windows shell UI, like I right-clicked on our taskbar button and chose close from there, but that would never go through some widget close method. That would just be Windows notifying us. And so that kind of collapses the code paths into a single funnel.
I have one more question. Just like a simple example, like suppose you had a dialogue with a button in it, and that was like it. Can you just like kind of draw on it what that would look like, what the hierarchy of that would look like?
Sure.
Where the widgets and all the stuff are?
Sure. So I'll erase this and try and do a cleaner one. I haven't actually written a new piece of UI in Views for a little bit since I've been working on other stuff, so forgive me if someone's refactored something and it's slightly different. But this is based on my memory of how things work. So maybe easiest to start with a button. So I have my button view, and then maybe it might be parented by some other content view that has some layout method that maybe nicely centers it or something else. And then this view is supplied to for a dialog box, there's another view that is its parent, which is called the dialog client view. And this guy actually has some additional stuff in it, depending on, for dialog boxes, there's an interface called dialog delegate that allows you as the user of a dialog box to define actions that happen when the dialog is closed. Sometimes there may be OK or cancel buttons, so you can define things like that. But let's just say I have a close button, so it supplies a close button as well. And so I get called back if you click on that. Otherwise, you can define what happens when you click on that. And then as a peer in the hierarchy, there will be a, what's it called? Maybe let's just assume we are running on, I'm trying to think, we're thinking, if we're running on Windows 7 with glass turned on, there will be a native frame view. And then the parent of these, there is a non-client view. And the parent of these is a root view. And then this is attached to a widget. Of type window, which is attached via the native widget interface. In the non-Aura case, to a native widget win. Which has the hwin message handler. And then somewhere out here is the hwin. And so when I receive a mouse move, the window procedure here gets the mouse move and then sort of forwards it through these layers to root view. And I'll talk about event dispatch in a little bit, but basically if I click down, click down and up, then this view will receive on mouse released, and then there'll be a button controller that's basically that button clicked in your code, which subclasses someone in here, whether you have subclass button to make this or you have subclass view to make this guy. Somehow you'll see that button was clicked and choose to frapinate or whatever that means. Does that answer your question? Or?
So like widgets never have parents or children, right? They just have a view.
Right, they have the root view.
And if I have, say I have another parallel hierarchy that only has a widget and a root view and nothing else inside it, you might have answered this earlier too. Can I just take this non-client view and reparent it into the other one? And I have everything just work?
The non-client view, this stuff here, that is set up for you automatically by the widget. Depending on the type that you create. So this is the other thing. There are different types of widget. Like I kind of briefly alluded to this, there's type control, which is just a root view. And you can just put stuff into it of your own, whatever you want. Type window creates this non-client view mechanism. And there are a bunch of interfaces that you can...
It doesn't have to be the non-client view either. I'm just wondering if you can take some view somewhere down in the tree of a widget and just reparent it into another widget's tree.
You should be able to, as long as none of those views do anything unfortunate when they get reparented. There is a method on view that you can override called view hierarchy changed. And some people do that. They will do like, when I am added to a view hierarchy, do all of my once only initialization. Most of the stuff in views shouldn't do that, like the core stuff, but there's a bunch of code in Chrome that does this. So I guess it just depends.
So when you initially said that it's unfortunate that people subclass, if I was to create this thing here that you draw, I will subclass a views, or I will subclass what do people do?
So, and I said it's unfortunate, but really that's the only way to do a lot of things. So it's unfortunate from my perspective of this is a bad design that I've done. But there's there are a couple of different ways. You don't always have to subclass. Traditionally, subclassing's worked well for specialization. So if there's a class that kind of does what you want, but you want to change some property of it in some way or some of its behavior, then and the thing that you're creating is like a special class of that other thing. So you can certainly do that. Like I said, we have checkboxes that are really just subclasses of buttons because they have a slightly different rendering and they have a slightly different interface that they notify. Actually, I think they even use the same interface to notify when their state changed. They have an additional property of am I checked or not. But fundamentally, just buttons. I think that's similar to Windows, where Windows, they're actually all considered button HWinds, just with different styles set to them. So you can certainly do that. And then what people also do is that this content view will sometimes be some class that is a subclass of view that they'll write. Let's say you have your Frobinate dialog box, and you'll do Frobinate dialog view, and you'll subclass view and make it this thing here, and you might have a label up here and other stuff. But this Frobinate dialog view might also implement the button listener interface that the button view provides. And so you would set the listener of this guy to this. And so it doesn't really need to be a view, it's just that that's the way it's kind of worked out. It's also possible to make something like this by composition. So you just create a view, and you create some other class that implements the listener for this. And then you also create a layout manager and set it on this guy so that you don't need a subclass view. That's an alternative, and that's something I'm exploring to find if there's ways that we can do more of that kind of thing, because I think that might be a little bit less
Never seen that pattern. I always see people subclassing a view.
I think it's a combination of it seems easier to subclass view and then write layout than it is to like go and implement the whole layout manager interface and then or figure out how to use grid layout's an awesome layout manager, and it's like it has a huge amount of flexibility, but sometimes you wonder what sequence of flags do I pass to it to get it to do the thing I want. Whereas with some layouts they seem like kind of simple, so maybe I'll just write layout and then I can control that. I think writing layout and providing preferred size and a few things like that are the reason that people will subclass view most often. So that kind of caps off the view side of things. Then on to our